AP Calculus AB, first derivative test number 22. So we're given this function, f of x is x cubed minus 6x squared plus 15. We're asked to find the critical values and find the increasing and decreasing intervals. I guess what I would ask you first is, can you visualize what a cubic function looks like to possibly anticipate what we're going to find here? So I guess I would start with that question, and from there I'm going to start doing this test here. We know that the critical values are where the first derivative goes to 0 or where the derivative is undefined. So let's do this. Let's take f prime at x, which I think is pretty simple here, isn't it? I'm going to take the derivative of this part, which is 3x squared, the derivative of this part, which is negative 12x, and the derivative of this horizontal line is 0, so we have that. We're going to take a look at this quickly for critical values and ask ourselves, is this function defined everywhere? And it is, right? It's polynomial, so we know it's defined everywhere. There's no number we could put in here that would make this undefined. So from there, I'm going to just ask the question, when is f prime at x equal to 0? So when is, and I'm going to go ahead and factor this out if you don't mind, 3x times x minus 4 equal to 0. Hopefully you can see why I did that. If I multiply this back and I get my 3x squared back, and I multiply this 3x times this negative 4, I get my negative 12x back. So when is this thing equal to 0? Well, it's equal to 0 when x is equal to 0, or when x is equal to 4, using the zero product property, right? So from here, if you don't mind, I'm just going to set this up. Here are the critical values. Here's one critical value. Here's the other. So I'm going to set up this table, and I'm going to set it up as intervals. So what I'm looking for is everything to the left of this. So I'm looking from 0 to the left of that, from 4 to the right, and then I'm looking for the place in between 0 and 4. So that's why the intervals come out looking like this. We have x is less than 0, right? That's to the left-hand side of this, but greater than negative infinity, right? The second interval is the interval in between this 0 and this 4. So when is x greater than 0 but less than 4? And then we want what's to the right of this. So when is x greater than 4 but less than positive infinity? All right? So that's how we got those intervals. And then what I'm going to do is just take some test values. And you have to be really careful on the AP exam. If you just put pluses and minuses, you get 0 credit. So we need to show some calculus here. So far we have calculus. We need some number that's between 0 and negative infinity. I like negative 1. We need some number that's between 0 and 4, and you don't have to use 1, but I like 1. And then some number greater than 4 but less than infinity, and I like 5, and you can use whatever you'd like. And then what I want to know is, what's the sign of that test? What's the sign of the derivative of that test value? So that is to say, what is f prime at negative 1? And f prime at negative 1, if you put it into this function right here, is equal to 15, I believe. And f prime at 1, I believe, is equal to 9. How can that be true? F prime at 1 is equal to negative 9, isn't it? Is equal to negative 9. And f prime at 5 is equal to 15. All right? So what can we get from that? What conclusions can we draw? Well, we know, right? We know what we can say here, that our conclusions are based on the sign of the derivative. If the derivative is positive, when we have then we're increasing on that interval, aren't we? And if it's negative, if f prime at any of these sample spaces is negative, we have decreasing. And somebody out there is saying, well, how do I know about the other ones? Well, if it's negative here, it's negative everywhere in here, because here it goes to 0. We can claim that by intermediate value theorem proves that to us. And then it's increasing here. Why? Because the slope in this interval is, at this place in this interval, is positive, so it's positive everywhere in there. Okay, so what do we know now? We were asked when is this thing increasing and decreasing? So it's increasing on negative infinity to 0 and 4 to positive infinity, isn't it? It's decreasing and these are the questions that are being asked of us, it's decreasing on the interval 0 to 4, right? And now what we have to ask ourselves, we're asked about critical values. So the relative extrema, so one of them, right, one of our critical values, right, here are the critical values again. So critical values are this one and this one. So what is f of 0? And f of 0, if we do that, we get f of 0 is equal to 15. So we get the point 0, 15. And why is that important? Because this is where the slope goes to 0. So we have this is a height here, and we need to figure out is this a max or minimum height. And the other place that we have that turn is at 4. So what's f of 4? And I just plug it back into the original function and found that f of 4 is negative 17. So we have the point 4, negative 17. So this is our, one of these is a max and one is a min. So this is relative max, isn't it? And this is relative min. Okay. Hope this was helpful. I'm looking for your comments. If you're not already subscribed, please subscribe. Oh, look, I actually proved this out for you a little bit. I graphed this function. In red is the function itself. And in green is the derivative of the function. And we can see that the derivative of the function does go to 0 at 0. And that means if you follow the derivative, it means that the slope is 0 here. And also, the slope of the function goes to 0 here at 4. And we know that crosses the derivative function is 0 here, and the slope of the function is 0 at 4 here. All right? Now, also remember I asked you to see if you could visualize what a cube looks like, and of course cubes have this kind of look to them, don't they? Okay, good work. Take good notes.